In this video, I'm going to solve an exponential, and I am going to use a logarithm in order to solve it. So first thing I'm going to notice when I'm solving is that the variable that I want is in my exponent. And that tells me that I'm most likely going to use a logarithm unless I get to a stage where once I've isolated this, I can rewrite the other side as the same base. And if you watched one of my other videos earlier, you can see me do that. But here, first thing I need to notice is that we're always going to attempt to isolate our variable. And when we're attempting to isolate, we're going to use SADMAP. So SADMAP is just your opposite order of operations, and I'm going to use it to isolate the exponential. So when I say the exponential, we mean whatever your base is, and then to the x plus or minus whatever. So here I can see even say x plus h or n. This is what we're trying to isolate. So in this case, I'm trying to isolate 2 to the x minus 1. Using SADMAP, the first thing I'm going to do is I'm going to add or subtract to the other side. I can see that I can add 5 to the other side. That's going to give me 6 times 2 to the x minus 1 is equal to 18. Next, we divide or multiply. So now I'm going to divide the 6 to the other side. That's going to give me 2 to the x minus 1 equals 3. At this stage, I have isolated this. I've isolated the exponential. Now I'm going to write in red. This is a common mistake. Something I see students do all the time is they try to combine these. They try to say that this is equal to 12 to the x minus 1 is equal to 18. This is wrong because we cannot multiply until we've dealt with this exponent. So we're not trying to combine things on this side. All we're attempting to do is to move stuff to the other side. So the operation here is multiplication, so we're going to divide it to the other side. Now, at this stage, this is where I said we could see if we could rewrite our bases as the same number. But there's no way that I can rewrite 3 easily as a perfect power of 2. So instead, we're going to utilize a logarithm. So what we're going to do, and this is kind of, there's different ways to go about this stage, but what I have found the most useful is to take the log of both sides. So just like you can divide on both sides, you can add on both sides, you can take the log on both sides. So we're going to take the log of both sides. But this is the key part. In order to make this really useful, use the same base as your exponential. So what I mean by that is here, the base of my exponential is 2. So I'm going to take the log base 2 of both sides. I don't really have room to write it here. So the log base 2 of 3. So I'm going to rewrite that a little bit beneath everything so we can see that slightly better. What I end up with is the log base 2 of 2 to the x minus 1 is equal to the log base 2 of 3. And why we do this is because one of our properties earlier, from earlier in the unit, tells us that if our base here and our base here are the same, this actually just simplifies to x minus 1. So once again, kind of similar to a conjunction we did just a minute ago, if you watched one of my earlier videos, is the fact that if your base of your argument and your base of your exponential are the same, because log base 2 of 2 is equal to 1, they kind of cancel each other out. All we're left with is the x minus 1. And so this side simplifies. So I'm going to say, kind of based off of step 2, I'm going to make this maybe like step 2.5, which is simplify the log with the exponent. So every single time it's going to cancel out as long as these two numbers are the same and leave you with that exponent, which means we're actually super close to being done. Step 3 is then to just isolate x. Once again, we are using SADMAP to do so. So all I need to do is to add 1. Now I've already taken the logarithm, so this is not going into the logarithm. That's its own thing. It's going to the outside. So I get x equals the log base 2 of 3 plus 1. And that would be our final answer here. Now sometimes if you have access to a calculator, you could evaluate this, or if you knew the number, you could evaluate it. And If we had known the number, we probably just would have rewritten it as a common base here. But maybe you did take the logarithm all the way out, and if you knew what this logarithm was, you could evaluate it. But in this case, we're not super confident with log base 2 of 3 because 3 is not a perfect power of 2. So we're just going to leave our answer in logarithmic form.